Welcome to Physical Sciences Consultorium. This video is part of the series How We Know the Universe. In the first episode, we saw how light can carry information across vast distances. In this episode, we take the next step and ask a deeper question: why does astronomy rely so heavily on indirect evidence? In astronomy, we almost never observe causes directly. We do not touch stars. We do not experiment on galaxies. We only receive signals from a distance. At first, this sounds like a serious weakness. How can a science be reliable if it never sees things directly? Indirect evidence does not mean guesswork. It means inferring causes from their effects. We use indirect evidence all the time. We infer wind from moving leaves. We infer gravity from falling objects. We infer thoughts from actions. What matters is not direct access, but reliable connections. Indirect evidence becomes trustworthy when the link between cause and effect is stable. Physics is powerful because it enforces this stability. Nature does not behave arbitrarily. This is why indirect evidence works in science. Astronomy is indirect by necessity, not by choice. The universe does not allow experiments. But astronomy compensates with strong physical constraints. Many effects must agree at the same time. When they do not, explanations fail. No human has ever touched a star. No probe has sampled its surface. Yet astronomers confidently talk about a star's temperature. How is that possible? Temperature is not hidden inside a star. It affects how matter behaves. And how matter behaves affects the light it emits. Hot matter glows differently from cool matter. This is not interpretation. It is enforced by physics. Once we observe a star's light, not every temperature is possible anymore. Some temperatures are ruled out immediately. Others remain allowed. Astronomers are not guessing a temperature. They are eliminating impossible ones. Brightness, color, and detailed light patterns must agree. If they do not, the model fails. This is critical. Failure is possible. That risk of failure is what keeps astronomy scientific. Astronomy does not claim certainty. It claims consistency and their physical laws. Models survive only if they continue to work across different observations and conditions. Indirect evidence is disciplined, not loose. Astronomy does not say, "This must be true." It says, "Given physics, this cannot be false." That is a weaker claim than laboratory certainty, but it is still reliable physical knowledge. Astronomy depends on indirect evidence because the universe allows no other option. And indirect evidence works because physics tightly constrains what effects are possible. That is why astronomy remains a science. Thank you for watching Physical Sciences Consultorium. If this way of understanding space science makes sense to you, this is exactly what Physical Sciences Consultorium exists for. We focus on how scientific knowledge is built, not just on what is known. If you found this episode useful, please like, share, and subscribe to the PSC channel. It helps this outreach reach more curious minds.